Welcome to the LLM Wiki series. I'm Bailing Zhang. Over the next several episodes we'll trace one idea, that the right way to give a language model knowledge is not to retrieve it on every query, but to compile it once and keep it current. Episode 1, The Memory Problem, and the Compile Paradigm. Let's start with a symptom you've probably felt. You open a chat assistant, upload a PDF, ask your questions. The next day you do it again, the same PDF, because the system remembers nothing from yesterday. Or you point a notebook tool at 50 papers, it indexes them happily, but ask it a question that requires combining 3 of those papers and it stalls, because it never pre-computed the connections between them. These aren't bugs. They're the predictable behavior of systems with no persistent memory. Nothing they learn accumulates. Step back and the cause is structural. Between 2023 and 2026, AI shifted from single-turn tools to persistent agents, systems that plan, act, observe, and revise over long horizons. An agent like that needs 3 things a chat box doesn't: persistent memory that survives across sessions, compounding knowledge, so each new source makes it smarter rather than starting from zero, and self-maintenance, so it keeps its own knowledge current. The tools era didn't need any of these. The agent era can't function without them. And here's the core contradiction. Agentic AI demands persistent, compounding memory, but almost all of the infrastructure underneath it is stateless. Every interaction begins from nothing, the model retrieves, answers, and forgets. There is no mechanism by which knowledge becomes an asset that grows. If we want agents that get better with use, we need infrastructure where knowledge compounds. So let's look at the dominant paradigm and ask why it doesn't. That paradigm is retrieval augmented generation, RAG. The recipe is simple: take a query, retrieve relevant passages from a document index, condition the model on those passages, and generate an answer. RAG earned its dominance honestly. You can update knowledge by updating the documents, you get a degree of source attribution, and it handles specific, long-tail questions well. But notice one design choice: RAG is stateless with respect to knowledge. The corpus is read-only, and every query starts fresh. That single choice is the root of 4 limitations. 4 limitations, and they compound. Statelessness: nothing accumulates across queries. Synthesis at the boundary: the model must integrate fragments under time pressure, in a single pass. Chunking pathology: text is split before any query is known. And the maintenance gap: when sources change, relationships and contradictions don't get repaired. Let's take them one at a time. Statelessness first. Imagine you ask a question on Monday. RAG retrieves the relevant passages and reasons over them. On Friday you ask the same question. The same retrieval fires, and the same reasoning happens again, from scratch. None of Monday's synthesis survives to Friday. Nothing compounds. For a one-off lookup that's fine. But for an agent meant to build expertise in a domain over months, throwing away every conclusion the moment it's reached is a profound waste. Limitations 2 and 3. Synthesis at the boundary: RAG retrieves fragments and hands them to the model, which must assemble an answer in a single forward pass, often from passages that are redundant or even contradictory. Questions that require integrating many documents, which institutions agree, which disagree, and why, are exactly the ones this serves worst. And chunking: embeddings operate on chunks whose boundaries were fixed at indexing time, before any query existed. A chunk that splits a table or crosses a topic boundary gets retrieved with a misleadingly confident similarity score. The 4th limitation is the maintenance gap. As source documents evolve, you can re-index them, but nothing updates the cross-document relationships, resolves newly introduced contradictions, or propagates a correction through everything that depended on it. Consider a clinical assistant that retrieves 2 guideline fragments which contradict each other, and presents both to a physician with no resolution. In a meaningful sense, that is worse than no system at all. These 4 limitations are not edge cases, they are what practitioners hit the moment they deploy RAG in high-stakes settings. So here is the shift. In a retrieval system, all the knowledge work happens at query time, every question triggers retrieval and synthesis from scratch. In a wiki system, the work has already been done. Before any query arrives, the model has read the sources, extracted the claims, detected contradictions, written cross-references, and organized everything. Karpathy framed this as compile time versus query time knowledge work. RAG reconstructs on every query, the wiki compiles once and keeps current. The two pipelines aren't even mutually exclusive, but the center of gravity moves to compile time. This is the heart of Karpathy's April 2026 proposal. Rather than querying a model anew for every task, you discipline it to maintain a persistent, compounding wiki, a structured set of markdown pages that accumulate knowledge across sessions and cross-reference their own entries. The human handles sourcing and direction, the language model handles the tedious bookkeeping, updating cross-references, filing changes, keeping indexes current. The wiki is the product. The LLM is its disciplined curator. The maintenance stays cheap because the curator never gets bored. Why call it compile? Because the analogy to software is precise. A compiler doesn't make your program correct, it transforms source code into a representation that's efficient to execute. The wiki does the same to knowledge, it transforms raw source material into a representation that's efficient to query, to maintain, and to audit. The gain is in the structure, not in the model's raw capability. The same model, given a compiled wiki instead of a pile of documents, answers faster and more consistently, because the hard integration work was done ahead of time, once. And this inversion changes the fundamental question we have to ask. In RAG, the unit of accountability is the passage, does this retrieved text support this answer? In the LLM Wiki, the unit of accountability becomes the artifact itself, is the knowledge base in a trustworthy state? That is a qualitatively different question, and the methods that answer the first do not answer the second. Holding on to that question is what the rest of this series is about. To recap, agents need compounding memory, RAG, by design, can't provide it, and the alternative is to compile knowledge once and keep it current. Think of it as a ladder, retrieve, compile, verify, constrain. Today we climbed the first step, from retrieve to compile. In episode 2, we open the hood, the three-layer architecture, the four operations that run a wiki, and the human-machine division of labor that keeps maintenance close to zero. See you there.